Hey everybody. Today we're talking about dates and times in R. Throughout this vid, I'm going to be working with the optical dataset, which you can download from my website if you're interested in following along with this video, link in the description below. I'm going to start by loading up Tidyverse and setting a minimal theme. I'll be doing one or two visualizations at the end of this video. And then I'll read in the dataset using the Tidyverse verb read_CSV. Okay, so let's start with dates. Dates are typically stored in R using the date class, and read_CSV is going to assign this automatically when it imports a dataset when it finds things that, look like dates. Let's glimpse this optical dataset, and we can see a variable that has the date class right away, DOB. And those are dates, and you can see that it is being formatted in year, month, day format. Here, let me resize this window just a tiny bit so you can see the full date for Alan Green. There we go. Now, internally, dates are stored as integers, representing the number of days that have elapsed since the 1st of January in 1970. And you can see that using as.numeric or unclass. So for the first few values in the optical dataset, looking at dates of birth, we can see these various numbers, representing days since January 1st, 1970. Negative numbers are going to represent dates before 1970. Now, you can do basic arithmetic with dates. You can do things like subtract them to get time differences, and those are typically measured in days. I'm going to use the diff command to get the differences between the dates of birth sequentially in this entire data set all at once. So you can see the time difference between the first and second observation, the second and third, the third and fourth. So this is doing lots of subtractions all at once. Notice that it does tell us right at the top that the time difference is being measured in days. Now, a lot of times when you import a data set, for whatever reason, you'll have a column that looks like dates. It's going to have the appropriate information, but it's not going to be automatically detected. And there's lots of different reasons this can happen. There is a built-in as.date function that is supposed to handle this, but is not particularly user-friendly, so I'm not going to advise to use that. Instead, I recommend the Tidyverse functions mdy, ymd, and so on. These are all included in the lubridate package, which loads with the core Tidyverse. And these functions do a really great job of parsing date formats as long as the order of the elements is what you specify. So for instance, the mdy command is going to accept text strings that represent dates in a month, day, year format, very common in the United States. So here I'm showing a vector, text dates, representing August 3rd, 2026, the release date for this video, in several different formats. You can see I've used an abbreviation for August, the full word, I've used slashes, I've used dashes, I've used nothing at all. In this last case, I've just used 2 digits for the year, while in others I've used 4. So this is a vector of length 5. Make sure that I've entered that. And then let's confirm that when we do mdy of that, we actually get dates. And you can see that already using just the printout because we see it in that familiar format, year, month, day. If we do the class of this vector, we can see that this does have the date class. By the way, that year, month, day format that's used for printing by default is really an ideal one for scientific applications. In particular, if you want to sort things, for instance, just in a file folder, dates are the way to go. It'll end up being chronological, whereas if you do a different dating convention, like here in the United States we do month, day, year, that won't be the case. But if you do need a different printing convention, you can change things using the format function. You can also build dates manually using make_date, another great lubridate function, and that's particularly useful when a dataset includes separate columns for year, month, and day. Here's a very simple example of that. I am specifying a year of 2026, a month of 8, which is August, and a third day, make date is going to put out that date object 2026-08-03, just as we would hope. Now, there's some great convenience functions for extracting date components. For instance, if you have this 2026-08-03, you might want to pull out the numeric day of the month, month of the year, calendar year. You might like to have a string saying whether or not the individual day was a weekday or what weekday it was. So some really useful convenient functions are weekdays from base R, which is going to take a bunch of dates and hand back the day of the week. So you can see that here for the DOB variable. And then some lubridate functions that will specify the year, month, or day of the dates in the string, in the vector that you're providing. So there are years, there are numeric months, and numeric days. Now, things get a little more complicated when we talk about date times, but only a little bit, unless you really want to get into the technical aspects of date times. Moments in time are identified most simply using the DTTM class. In the optical data set, the appointment date variable has this class. The variable is called appointment date, but it's actually appointment dates and times. And let me get that to print out a little bit more fully, at least for Alan Green. So you can see that the appointment time here was November 25th, 2019 at 12:59 and 36 seconds. So just a little bit after lunchtime. Date times are relative to location, however, because we have things like, because we have time zone considerations here. So the way this is printing out right now is actually ambiguous. This time will represent a different moment, a different instant in time, depending on where the time is being recorded. In general, R defaults to UTC time, sometimes called Greenwich Mean Time, though there are cases where your machine's local time will instead be used. So it's good to have a time zone specified explicitly. We can extract or assign time zones using the TZ function. So for instance, here on line 87, TZ parenthesis optical dollar appointment date is going to give me the time zone for those dates in this data set, which of course is going to be that default of UTC. Now, I'm in the Chicagoland area in the United States, so these data might be recorded in that time zone. On line 88, I'm going to make that assignment. So let's let R know that these dates are supposed to be America, Chicago by command entering on that. And then we can verify that that time zone is now being honored using TZ parenthesis optical dollar appointment date again. Now, oftentimes you just want to convert times rather than just overwriting the location. So when I did this TZ command before, it kept the times exactly the same, but just changed the time zone label. So it's representing a different instant in time, actually. If I want the same instant in time, just recorded using different time zones, for instance, in different places, I use with underscore TZ. So the appointment dates, the first few now are shown here. Let's now get what those times are how those times would be represented in UTC, in Greenwich Mean Time. There we go. And you can see that there's generally a 6-hour difference, sometimes 5, depending on whether there's daylight savings time involved. If you're interested in seeing all the available time zones, Olson names will give you a list, or rather a vector, of about 600 values. Maybe I'll just print that out for fun. There you go. All sorts of variety here. This is stressing just how complicated date times actually are if you want to get into the technical stuff. There are a lot of different time zones. If you need or want to see what your current settings are in your system, you can use sys.timezone to see the time zone and sys.time to see our actual system time. You can also consider the now function from the lubridate package. All right, let's wrap up this video by doing one quick visualization. I want to take this optical data set and make a histogram of appointment dates. So a very basic plot. The only reason I'm doing this really is to illustrate the fact that ggplot is going to format date times logically when it runs into them. So a histogram we normally think of as being for quantitative data. Date times are like integers underneath the hood, so it makes sense this would work. ggplot is just putting in nice labels for us. Now, if you want to start tinkering with the exact format of that label, you generally want to start with the scale x date command, which you can add straight to your ggplot. Last thing I'll do is to hit the render button. Let me show you what this Quarto document that I've been writing throughout this vid is actually going to look like. There we go. As usual, I will post all of this onto my website. Again, link in the description below, so you can follow along not just with the data set, but also with the actual code.